Hey, what's up guys? Mr. Flores here, and this is a video that deals with solving quadratic functions, okay? Now, we've already done this graphically, but we never done it algebraically. So what I want to do is kind of go over what does it mean to solve a quadratic when you look at the graph, and then I'm going to relate that back to the factoring or algebra portion. So when we talk about solving quadratic functions, or when you talk about solving a function, really, what you want to do is you want to find the x-intercepts, okay? So we know the x-intercept is there. We know there's an x-intercept there. So we know that in order to solve this, the x-intercepts are going to be, for this one, it's 2, 0, and 4, 0. Okay. And generally what we know about every x-intercept is that it has a y value of 0. Okay. So if you were to ask you, or if I were to tell you the zeros of this would be x equals 2 and 4, okay? Because that's what's going to make this function 0, aka the x-intercepts, all right? That's what it means graphically. But when we talk about it algebraically, we go back to something that you learned in your earlier years, but you definitely probably forgot about. And that's called the zero product property. So the zero product property, says that if I take A and B, multiply them together, it equals 0 if and only if A is equal to 0 or B is equal to 0. Okay, so let's look at an example. Say I have 3x equals 0. Well, we know that 3 is 3, and if you multiply by x and it equals 0, that means that x has to be 0. Likewise, if you do x times 3 is equal to 0, you also know x has to be 0. Okay, so basically what the zero product property says that if you take two things and multiply them, and it's set equal to 0, one of those things has to be 0. So really, when you're solving, a quadratic, when you're solving a quadratic, it kind of comes out like this. So say I factor and we get x minus 3 times x plus 2. Okay, to solve it, I would just set it equal to 0. Okay. Now, when we look at this, we know that we have x minus 3 times x plus 2, and the answer equals 0. Well, looking at the zero product property, we know that either x minus 3 is equal to 0, or x plus 2 is equal to 0. Really, what our job is we want to find out what x value will make that true. So what you do is you take both pieces separately and set them equal to 0. So we know x minus 3 equals 0, add 3, and you get x equals 3, minus 2, x equals negative 2. Okay, so when you solve this, your answer is x equals 3 and x equals negative 2. Because if we plug a 3 and you get 3 minus 3 is 0, which would make the whole thing 0. Or if you plug a negative 2 in, it's negative 2 plus 2 is 0, which makes the whole thing 0. Okay, so really solving quadratics is just an extra step. Okay, so we're going to just do a problem and hopefully it starts coming to you. We have 4x squared plus 12x. In order to solve it, you always set it equal to 0. Okay, so we know that we're going to have to solve this problem, so we're going to have to find out some x's in the end. But you do it the same way as factoring. So we notice if it's a binomial, there's two terms, we need to find the GCF. The GCF between 4x squared and 12x is 4x. We're left with x plus 3, and it's still equal to 0. Well, if we look, we have 4x times x plus 3. We need to take 4x, set it equal to 0, x plus 3, set it equal to 0. Because we need to find out the two numbers we can substitute in for x that'll make it equal to 0. And that's really all solving is. So divide both sides by 4, and you get x equals 0. There's one solution. Minus 3, x equals negative 3 is our other solution. Okay? So when you're solving these, you're going to get two answers, generally. There's some cases when you might not. We'll find those out later on. So x equals 0, x equals negative 3. Now I have a trinomial. All right? First thing, let's see, can we pull out a GCF? The answer is no. All right? But since the coefficient is 1, we need two numbers that multiply to 42 that are going to add to negative 13. Again, we have to set it equal to 0 since we're going to solve. All right, 42 and negative 13, the numbers are going to be negative 6, negative 7, negative 6, negative 7. Okay, so if we were just factoring, our factored answer would be x minus 6 times x minus 7. Since we're solving, though, we have to set it equal to 0 and find out what x values will make it equal to 0. Well, again, you just take each piece separately, set it equal to 0, because the zero product property says that either of these can be 0. So we add 6, add 7, and our final answer is x equals 6, x equals 7. So really the difference between solving and factoring is that in order to solve, you must factor the problem first, then go an extra step and find out when each of the separate factors are equal to 0. Okay, so it's really nothing crazy, but all right. So we have x squared minus 4x equals negative 3. The only thing here is that in order to solve, it has to be set equal to 0. So this negative 3 we need to bring to the left side. So what we can do is we can add it. So now we're at x squared minus 4x plus 3 equals 0. Now we can go ahead and factor it and solve. So two numbers multiply to 3, same two numbers add to negative 4. All right, I'm going to say it's negative 3, negative 1, negative 3, negative 1. So now we get x minus 3, x minus 1. This is the factoring we have to do. But then to solve it, again, we still set it equal to 0. When we take both pieces, we get x minus 3 equals 0, x minus 1 equals 0, add 1, add 3. And you get x equals 1 and x equals 3. Okay, so again, this would be the factoring. The solving is the extra step to find out what is x actually equal. So if you plug a 1 in, it would equal 0, or if you plug 3 in, it would equal 0. All right, hopefully you guys are starting to get this. All right, let's look at this problem. So we have 5x squared plus 2x minus 3. Since the leading coefficient's not a 1, we hope that we can factor out a 5, but we can't because it's not common between 2 and 3. So this is one of the hard factoring ones, which we'll use the box method. So you're going to multiply 5 times negative 3. So what times what equals negative 15? What plus what equals positive 2? Okay, so we know that the term, it's going to be 5 minus 3, 5 minus 3, since it satisfies the equation. Okay, then we have to make our box, since this is the longer factoring one. So box method, top left, I'm going to put 5x squared. Bottom right, negative 3. Here I'll put 5x. Here I'll put negative 3x. Okay, and we factor out what is common. So 5x squared and 5x is a 5x. Negative 3x and negative 3 is negative 3. This is just x. This is just 1. So our factored answer is going to be 5x minus 3 times x plus 1. But since we're solving, we have to set it equal to 0. Do them both separately. So 5x minus 3 is equal to 0. X plus 1 is equal to 0. This one we must add 3. So you get 5x equals 3. Divide by 5. And you get x equals 3/5. Or for this one, you just subtract 1. And you get x equals negative 1. Okay, so this one, the two answers are x equals 3/5 and x equals negative 1. Okay, again, you always still have to be able to factor it. If factoring is difficult for you, which I'm sure it might be for some of you, just practice. Come see me, stay after, rewatch the videos, Google it. I mean, there's tons of ways you can practice it, but you need to understand how to factor, or else you're going to struggle for a good portion of the remainder of the year. Especially when we get into polynomials and rational expressions, factoring is huge. If you can't do it now, you won't be able to do it later, and you're just going to struggle. Okay? Because you must factor before you can solve. This extra step is the solving part. This is just the factoring. All right, and that's the last one. I hope you guys understand it, that solving is just an extra step that's added on to factoring, so it's nothing too crazy. If you have questions, let me know. Check out the other videos and do some problems.